Alright, this is the workshop video. We covered structure, execution, parameters, plots, drawing, and coloring. And now let's put it all together and build a real indicator from scratch. We're gonna build the Ichimoku Cloud. It's a Japanese indicator with 5 lines and some displacement tricks. Some parts we can handle with regular plots, but others may need OnRender logic. By the end of this video, you'll have built the whole indicator yourself. So let's do it. What is Ichimoku and why do traders use it? Ichimoku Kinko means one glance equilibrium chart in Japanese. The idea is basically you can see trend direction, support and resistance, and momentum all at once. It has 5 components and they all work together. Here is the basic trading logic. When price is above the cloud, you're in an uptrend. Below the cloud, downtrend. The cloud itself acts as support and resistance. The thicker the cloud, the stronger the support or resistance. Here we can see red Ichimoku Cloud, and here at this moment it acted as a resistance. Tenkan-sen, the blue conversion line, it's the midpoint of the highest high and lowest low over 9 periods. Think of it as a fast signal line, no displacements, draws right at the current bar. Kijun-sen, the red baseline, same calculation but over 26 periods, slower, more significant, and also with no displacement. Senkou Span A, the green line, is the average of Tenkan and Kijun. But here's the trick, it's plotted 26 bars into the future. That's forward displacement, okay? Senkou Span B, the dark red line, is the 52 period midpoint, also plotted 26 bars ahead. The area between Span A and Span B forms the cloud. And Chikou Span, the purple line, is just the current close price but plotted 26 bars backward. It lets you compare current price to historical price action. So we got 3 types here: no displacement, forward displacement, and backward displacement. We'll use the right tool for each part. Okay, before we write any code, what's the first thing we do? We start from our template, right? So I'm gonna copy that and create a new file. We're gonna call it Ichimoku Cloud. I'm gonna paste it here, remove the TWM generated code, and rename the class name to Ichimoku Cloud. I'm gonna change indicator name, and I'm gonna generate new GUID. Okay, now the parameters. Ichimoku has 4 key numbers plus colors for everything. Okay, so first one is Tenkan period. So I'm gonna pass it here. I'm gonna rename it to Tenkan period. Then I'm gonna copy it 3 more times for Kijun period, Senkou B period, and displacement. Okay, we got 3 periods for calculations plus displacement for Senkou and Chikou. We need to set default values for these parameters. Go to set defaults. We don't need these no more. Okay, so default value for Tenkan period is 9, 26 for Kijun period, 52 for Senkou B period, and 26 for displacement. Now we have to add color parameters for each Ichimoku line. I'm gonna rename the line property we already have to Tenkan, and I'm gonna repeat it 7 times. And let's remove that. Okay, next we have plots and series. We have 5 lines, which means 5 series, which also should mean 5 plots. Here you go. These are the public series that strategists can access. We'll also need some private fields for plots and helper series, but let me set up the plots first. We don't need the main plot no more, and okay. The plots. Here's where we need to think. 5 lines, but they behave differently. Tenkan and Kijun, no displacement. Regular plots work perfectly. Chikou has backward displacement, so we're gonna write it to previous bars. Senkou A and B, forward displacement. They need to draw into the future. Plots can't do that. We'll need OnRender for those. Plus, we wanna fill the cloud area between them. So let's create plots for all 5, but we'll only use Tenkan, Kijun, and Chikou as visible plots. Senkou will show in the data box, but OnRender will draw the actual lines. Okay, here I have 5 plots. But we're also gonna need helper series for raw Senkou values. These helper series are gonna be used on render method. The main Senkou A and B series, they will store displaced values for the data box. I'll explain more when we get to actual calculations. Now let's create plots. We don't have main plot field anymore, so we can just rename it to Tenkan plot. Color is gonna be Tenkan color. We're gonna have fixed thickness and no line and chart type. And we're gonna add this to the pane. Now I'm gonna repeat this 5 times because we need all 5 values to be displayed in the data box. And for Chikou plot, we're gonna make it it dashed, and we're gonna add plot colors equals new color map for dynamic coloring. I'm gonna comment it out for now. Later, when the line is actually plotted, I'm gonna show you why we need this. We have parameters for colors, but we actually need to set the defaults. Okay, so here I have the colors for actual lines and light green with dark red for cloud color. Okay, so we've set defaults, we've created plots, now we have to initialize series. As you can see, we have old parameters here, so I'm just gonna rename it to Tenkan series and Tenkan plot. Just like that, and we also don't need plot colors. And we're gonna repeat this for the rest of a series. Okay, we initialized normal series, but we also have Senkou and Senkou. So we've initialized series. Now, do we need to initialize indicators? No. So I'm gonna remove that and I'm gonna stop calling this method. Okay, next one is apply plot style. We don't need that. We only need to paint Tenkan and Kijun plots because Senkou A and B are handled on render and Chikou has dynamic coloring. And reset fields, we don't have any stateful fields at this moment, but we're gonna keep it. We may need this in the future. So we've finished with onStateChange method. We are now prepared for onBarUpdate method for the actual logic and its calculations. And for this particular indicator, we're not gonna use this if statement, we'll do something else. So for Chikou, we're gonna have current bar greater than displacement minus 1. Because current bar starts counting from 1. Here we're gonna assign Chikou at the displacement minus 1 position, the current close value. Chikou is very straightforward. But in order to avoid making this calculation 2 times, we're gonna create a variable called offset and we're gonna assign displacement minus 1 to it. And we're gonna use this variable here. We also need to assign color to the plot. But you can see an error here. Cannot convert color to a brush. It's because we have plot colors using brush type and Chikou color has color type. In order to fix this error, we simply create brush out of this color. New solid color brush and colored as a parameter. Okay, you might think we are done with Chikou plot, but actually no. Imagine we have 500 bars or 1000 bars and we create new brush object each time. As a result, we're gonna have 500 brushes, but we don't need so much. We can use one brush for each 500 instances. In order to fix it, I'm gonna create a field and we're gonna use it for plot colors. So let's call it Chikou brush and let's go to the fields region and create private solid color brush, and on reset fields method we're gonna reset Chikou brush to our new value, and we're also gonna freeze this brush. That's for better performance. With this line of code we are telling that this brush is not gonna change. What about for other lines? Remember this pattern that I removed recently? We kinda need that. For our main period, we're gonna use Senkou B period. This is our longest lookback. If we are not at this stage yet, we're gonna just assign input values to our series. So now we can start calculating other lines, okay? We'll start with a Tenkan. Tenkan is a midpoint of highest high and lowest low over 9 periods. So I need to find the highest high. Actually, let me write a helper for this, and it's gonna take period as a parameter. In our case, we wanna get Tenkan line, so we're gonna pass Tenkan period. First reason why I create method for that is to encapsulate logic. Remember the Tenkan formula? We need to have highest high, lowest low, and divide them by periods, blah blah blah, okay? So we need the actual value of highest high and lowest low. We don't have to be bothered with actual highest high calculation, we just need the value. Second reason why I'm gonna use it is because we're gonna need highest high for other lines as well. So I don't want to repeat the calculation logic. I just want to call this method for each line that needs highest high, okay? We actually already calculated highest high in the previous video, so I'm not gonna comment on that. We're gonna rename argument to the period and we're gonna leave it just like this. Go to the Tenkan and keep up with the calculations. Okay, we also need lowest low of the Tenkan period. So I'm just gonna copy highest high method. I'm gonna rename it to lowest low. I'm gonna rename the variable by pressing Ctrl+R and I'm gonna call it lowest. Hit enter. I have it renamed everywhere. And instead of high, we're gonna use low. And instead of min value as a default, we're gonna pass max value. Because if we would have kept min value and we're trying to look for lowest value, we wouldn't find anything lower than the min value. right? Okay, so that seems to be correct. Now, we also have to divide this by 2. Here's a mistake actually. I forgot to put sum of the highest high and lowest low in brackets. Now that's correct. Okay, Kijun line. Calculation is literally the same. We're just gonna use Kijun period. So I'm gonna copy that. I'm gonna assign Kijun and I'm gonna use Kijun period. So these two are straightforward. We calculate the midpoint and assign to series. Done. Now Senkou. This is where it gets interesting. See this pattern? First we calculate the row values and store them in row series. Then, for the main series, we're gonna look back offset bars and store that older value at the current position. Just like that. So when you hover over bar 100, you see the Senkou value that was calculated at bar 75. That's what forward displacement means for the data box. The actual line drawing into the future, we're gonna handle this on render method. Okay, let's save it and see what we have so far. I'm gonna compile it, add indicator to the plot, Ichimoku Cloud, and hit OK. Here you go. Yes. It differs from the version you saw at the beginning of this video. Let's see what we got so far. I have data box open and I want to see values. We have Chikou 0 because it goes back 26 bars. If we go here, we have the values. But I don't like this connection. Value 92,000 connects to value 0. Okay, let's think about why this happens. We don't plot Chikou values for current bars. We only plot them 26 bars before. Let's take a look at that. So right here we plot Chikou line with our brush, purple color. But for current Chikou values, 0, we don't need to have any color, right? So let's set this actually for Chikou plot colors. So we're gonna set brushes dot transparent. Now let's test it. I'm gonna zoom in and I'm gonna reload it. Okay, it didn't work for some reason. Why is that? Aha, remember the beginning of this video where we created plots? That was here. Let's remove that. Reload and see if it works. Here you go. Okay, so far we implemented basic plots and series. Now it's time to get to the OnRender part. We need to go to OnRender method because Senkou has two problems. First, the regular plot draws the displaced values at the current bar position, but we want them drawn 26 bars into the future. Plots can't draw beyond the current bar. Second, we want to fill the cloud area between Senkou A and B. Plots can't fill areas. Let me add the fields we need. You see we have field for Chikou brush. We need the same stuff for pen. That's the object we use on render. We also need color for cloud fill, just like that. And we need to make sure to reset them at reset fields method. We assign null to them. Now we can get to actual rendering. We have a method that we need to override that's called OnRender, and it takes drawing context as a parameter. First, we need safety check. If we don't have a chart for some reason, or current bar is less than the longest lookback period, we return early. We need to make sure that our pens for drawing objects have been set. I'm gonna create a helper method, ensure pens, and what this is gonna do is if our pen is null, which means it hasn't been set, we're gonna call it create pen, and it's gonna take color and thickness of the line. And in order to create pen, we need brush variable, and we create pen knowing brush and thickness, and we're gonna return that pen just like that. Perfect. So I'm gonna repeat that for Senkou B, and for cloud color we're using brushes, so we're gonna create them differently, just the regular brush creation, and we're gonna repeat that for cloud down. Okay, now we need to get visible range, so we only draw what's on the screen. Okay, so I'm gonna create a separate method for specific logic related to drawing clouds. I'm gonna pass drawing context to it and visible range start and end. I'm gonna leave this method empty for now, so we could continue with our higher logic. After drawing clouds, we need to draw lines. So I'm gonna create another method for lines, and I'm gonna pass the same drawing context, the data itself, so that's gonna be series, in our case Senkou A row, then the pen, then the visual range, start and end, and the offset. I'm gonna copy that and change it to B Senkou. Okay, so we have our main logic. Draw cloud, then draw lines. Let's start with specific logic related to drawing lines. Okay, that's gonna be simple. First, as usual, we need to have safety check. If we don't have series or pan, we return early. Okay, let's think about how do we actually plot the line. First, we're gonna need the line going from start to current bar, but then we're gonna shift it to the right by a certain amount. So in this case, the end value isn't enough. We need to have 26 bars more in order to have enough values. So for that, we have variable data start, and it's gonna be visual start minus displacement. Okay, but what if visual start is 0? We are here and there is no more data. In this case, we're just gonna cut it to 0. That's how you do it, okay? If we go negative numbers, data start will be 0 and data end is gonna be our current bar. We're gonna add another safety check. If data start is greater than data end for some reason, we're gonna return early. Now we can start looping from our start data till the end. We're gonna use for loop for that. Okay, first we're gonna create variable for value from our series, and we're gonna add safety check for loops. In our case, if value is none or equal to 0, we go to the next iteration. That's what keyword continue means. But if the value is okay, we can start our logic. Okay, so far we have current bar index till the end minus displacement value. But we're gonna plot it with shifted values. We need to have current bar shifted by displacement value to the right. So to implement this, we're gonna create a variable draw index. The variable I, in our case, is index of each bar going one by one. Okay, it starts from the end and goes up until current bar. And in order to get shifted value that we're gonna assign to draw index variable, we're just gonna take I and we're gonna shift it by displacement variable. Okay, so we have shifted indexes, right? But to actually draw a point, we need to have X and Y coordinates. So we need X and we have our bar index. So we're gonna need a method that's gonna calculate X position from candle index. I'm gonna call it bar to X, and for Y coordinate, we actually need to know price, which we already have. So I'm gonna create a method price to Y. I'm gonna type another safety check just in case we don't have valid coordinates. And if we do have OK coordinates, we're gonna simply create point variable, new point, X and Y. Okay, we have a point, but our indicator lines are not just points or dots, right? They are points connected with a line. So in order to implement this, we need last point, which is gonna be null. And inside for loop, if we have last point, we can draw line. And we're gonna assign current point to our last point. Just like that. We loop through each bar, get the value from our raw series, but here's the key. We add displacement to the bar index before converting to X coordinate. So bar 74's value gets drawn at bar 99's position. That's forward displacement. Then we also track the last point so we can draw lines between consecutive points. So drawing context.drawLine connects them. Now let's get to coordinate helpers. I'm gonna create the methods, and here I'm gonna use the code that I've written before. Bar to X converts bar index to pixel X position, okay? But here's the trick. For bars beyond current bar, there is no data yet. So simple chart.getX by bar index won't work. That's why we extrapolate by calculating bar width and projecting forward. That's how we draw into the future. And price to Y is simple. Just convert price to pixel Y. Okay, the cloud fill is the visual payoff. We need to fill the area between Senkou A and B. First we're gonna collect the points, just like we did in drawLines method. Then for each pair of consecutive points, we're gonna create a four-sided shape, and we're gonna fill it. Here's how correct implementation looks like. Let me walk through this. First, we collect screen coordinates for both Senkou lines into lists, points A and points B. Same displacement logic as in drawLine method. Then we loop through pairs of consecutive points. For each segment, we check which line is on top by averaging the values. Okay, this formula. That determines green or red. Then we use stream geometry. We open a context, begin figure at first point, then we connect line to the second point of A, then to the second point of B, and then to the first point of B. 4 points, closed shape. Then draw geometry method fills it. And we repeat that for every segment and we get the cloud. Green when A is above B, red when B is above A. And we extend it into the future just like with the lines. Now let's test it. And reload. Okay, all of the lines disappeared. That's because I have an error in reset fills method. Chikou brush equals to null. We have to remove that. Okay, let's save it and reload. Look at that, all 5 lines working, right? Tenkan and Kijun from regular plots, no displacement. Chikou lagging behind using color map. That's the dashed line, as you can see. And Senkou Spans extending into the future with the cloud fill. That's OnRender. We can see all 5 values. That's a complete Ichimoku Cloud using the right tool for each part. And that's it. You just built Ichimoku Cloud from scratch. That's real world indicator development. You analyze what each component needs and pick the right tool. Plots are easier when they work. OnRender gives you full control when you need it. And with that, you just finished TWM Essentials 102. You went from knowing nothing about TWM Core to building a professional indicator with multiple visualization techniques. That's huge. When you're ready for the next step, TWM Essentials 103 is all about strategies. Taking these indicators and turning them into automated trading systems. But for now, go build something cool with what you learned, and see you in the next course.